Since our beginning, mankind looked up to the stars and dreamed of one day visiting other worlds, seeing what it was like on other planets, and planting the roots of humanity throughout the stars. Interplanetary living and travel have been deeply ingrained into our culture. Many pieces of science fiction involving the travel and living between or on different planets. Mars, in particular, has been the focus of many works of science fiction, describing and dramatizing what it would be like to live on the red planet. What these works typically do not address is what challenges and obstacles the characters had to overcome to establish a livable colony on Mars in the first place. The sheer amount of differences that between our planet and the red planet present many problems related to the livability that aren't faced here on Earth. Aside from the obvious differences in color, there are 1,001 facets about Mars that make Mars unlivable without proper scientific solutions. Perhaps the most obvious and well-known challenge facing would-be colonizers is the lack of water on the Martian surface. On Earth, water was instrumental in the development of early civilization. Without exception, every early civilization developed around a source of water. Early Mesopotamian Sumer around the Tigris and Euphrates, Egyptian society around the Nile. All human life revolves around the presence of water to aid in agriculture. Mars, as is obvious by its red appearance, is obviously lacking in usable water on its surface. This presents the clear and obvious problem for would-be colonizers, for who the lack of water would prevent any day-to-day farming activities. While NASA has confirmed the existence of flowing liquid water on the Martian surface, almost all of it's negligible, and almost all of the actual water on Mars is under the polar ice caps. Now, it's an important distinction. The ice at the polar ice caps isn't actually water. It's actually dry ice, which is made up of frozen carbon dioxide. The real water is actually under the ice caps, so it wouldn't be just a matter of settling at the poles and melting the ice. Settlement at the poles would have to pump up the groundwater in order to use it. Simple enough, right? Except no. Living at the poles brings us to another problem with Mars. Its temperature. The max temperature at Mars' equator is 70 degrees Fahrenheit, while the temperatures at the poles, where the water is, can easily go to negative 225 degrees. Not particularly livable. The temperature differences would result in problems with temperatures with the human body and the structural materials that are used in the colony. And with all these problems relating to water, another question and obstacle are revealed. What would the colonists do for nourishment on Mars? Well, one option is to receive perishable shipments from Earth on a regular basis. That idea is expensive and become unsustainable when the colony grew in size. Instead, the colonists would inevitably turn to farming. Farming on Mars has been dramatized in the recent film The Martian, where stranded astronaut Mark Watney must grow potatoes in Martian soil in order to survive on the planet as it waits for rescue. The film has some interesting accuracies and inaccuracies related to farming on Mars. In the film, Watney uses normal Martian soil, fertilizes it with human waste, and waters it from the resulting water from the combustion of leftover rocket fuel. Watney's endeavors are technically feasible for one reason. He didn't actually use water from Mars. Instead, he used water that he himself created. You see, the only problem with farming on Mars is the water, not the soil or the fertilizer. As you can see, Martian soil has all the essential nutrients for healthy plant growth. The only issues are the potentially large amounts of perchlorates that could be present during growing, which is a health issue for humans eating the produce. Perchlorates are found on Earth and are a problem with farming here as well. The EPA even regulates the amount of perchlorates that can be in our food because they can lead to problems such as hyperthyroidism or even cancer. Exposure to such a carcinogenic substance like this is extremely dangerous and would have to be addressed in the future should Martian agriculture become a reality. The thing is, perchlorates are much more common in Martian water than is in Earth water, which means normal water from Mars would need to be treated before it was safe to use in agro. But toxic water also is a severe hazard to any other sediment, which is why finding a method to gain access to large amounts of water is tough enough. A method to efficiently treat perchlorates must also be found and available to colonists. While these issues regarding food and water may be the most pressing, there are several other miscellaneous problems facing potential colonists. These problems include gravity, planet size, and even overall terrain. Firstly, Martian gravity on Earth is much weaker than that on Earth, which would have some unforeseen consequences. Astronauts coming from long-term exposure to zero-G experience severe muscle and bone atrophy due to the lack of stress in the body, which makes adjusting to Earth gravity again very difficult. These issues, particularly in bone atrophy, take astronauts an extremely difficult time readjusting to normal life on Earth. The gravity on Mars is 38% that of Earth's. For this reason, exposure to Martian gravity, while not having quite the same effects as zero-G, would also severely hamper colonists should they choose to go back to Earth. This is because the timeline of exposure would be much larger due to the colonists actually living on Mars. This makes Earth-Mars living extremely difficult to do. Once you go to Mars, it would be physically difficult to come back. Additionally, the size of the planet yields a longer overall day length, with about 40 extra minutes in the 24-hour cycle. While this would eventually mess up calendars for people coordinating on Earth and Mars, it would also have the more serious issue of messing up with circadian rhythms in humans. While scientists have shown that some humans can in fact adjust their circadian rhythms to a Martian day, it's a difficult process, and the shift would exacerbate anyone's current sleep problems. Finally, the terrain of Mars would make transport difficult, with the barren deserts and large valleys in the Martian landscape, not to mention the brutal surface temps at night. Moving across the planet on land would be a difficult prospect, hampering colony expansion and interaction, as well as making it simply harder to get places. One must remember that Mars is not the planet we as humans evolved for. Our specs are for Earth, and in order to live on Mars, we must make adjustments to the facets of the Martian planet or how we as humans do things. The environment of Mars is a challenge to humans, but it is potentially possible for us to live there in the future.